Saxon Algebra 2, lesson 46. It's kind of two separate topics, but I'm lumping them together because I just feel like it. We're going to talk about radicals. We're going to talk about fractional exponents. Good, solid algebra calculations. No fussy words or trig functions or anything crazy like that. Let's dive in. I'll teach you what you need to know as we go. Simplify. Now, this is the way John wrote it, and this is the last time I'm going to write it in his gibberishy way. Okay, this is what John did. Here's what I don't like. He's got fraction pigs living in single houses. No. He's got floaty numbers on the outside. We can rewrite this so it doesn't look so crazy. Here's the way I'm going to rewrite this. The whole numbers go up to the numerators, and we split the pigs into separate houses, which we are allowed to do. That's totally allowed. Wolf goes up. Pig splits into separate fractions. That stays more or less the same. If you want to put it over a 1, if that gives you closure, by all means. But don't copy this nonsense out of the book. Fix it so it looks like this. Bump the whole numbers up and split the fraction into separate pig houses. Okay, now we have something better to deal with. We can see that these guys look more or less the same. He's kind of an oddball. Let's deal with these guys first. The first problem that I have with the way this looks is these denominators. I don't like rational denominators. I don't want to deal with them. So, step 1. Rationalize denominators. All right. Remember, there's no equal signs here, so we're going to have to be doing all of our adjusting top to bottom. So, let me use a different color because that's always fun. This one I want to multiply by square root of 7 over square root of 7, right? Because that'll give me just a nice 7 on the bottom. This one has to be square root of 2 over square root of 2. Okay, that'll fix both of these. Now, I don't need to rationalize this denominator, but it's annoying me because this is a really big number and I think we could make it smaller. So I'm going to split this into 7 times 8. Right? Any two numbers that multiply. But the 8, okay, I can break that down. That's 3 2s, right? Okay, prime factor trees help us break down radicals. They're a super great tool. Now, I'm going to be able to bring out a pair of pigs as a single pig out here, and I'm going to multiply 2 times that wolf. That's going to leave me with those two factors on the inside. All right? Now, I'm going to go through and fix all of this. Ready? This becomes 3 times the square root of 14 over 7 minus 5 times the square root of 14 over 2 plus, let's see, 2 times 3 is 6 times the square root of 7 times 2, 14. Oh, wow. Things have taken a turn, haven't they? I feel better about that. So our second step, which I squeezed in, is we simplified a radical there. So we simplify anything big and beastly, all right? Things are looking really good. I like the way these three things match. I wouldn't want to ruin that. But before we can combine them, they have to have matching denominators. So that's our step 3. Match denoms. I like to abbreviate that because it makes me think of calling them demons, and you know. Sometimes you just have to own what you are, right? And those denominators are demons sometimes. Okay, so now what we're going to do is we're going to find the least common multiple. It's just like we always do whenever we need to make denominators match. We find the least common multiple. This time it's 14. And we're going to have to multiply every single one of these top and bottom because we can't combine them until the denominators match. We also need to have the radicals match, but that's looking good. So this one, if our LCM is 14, then this one needs to be multiplied by 2 over 2. And this one needs to be by 7 over 7, and this needs to be by 14 over 14, right? And sometimes it helps at this point to go, oh yeah, I have a 1 there. All right, so now we know what to fix everything by. Remember, this is a wolf, and thusly he multiplies by that wolf. So it's 6 square root of 14 over 14 minus 35 square root of 14 over 14 plus, that would be 84. 84 square root of 14 over 14. Yay. Denominators all match. Radicals all match. Interestingly, it's the same number. It wouldn't have to be, but that's kind of cute. And so now we can combine these for all that we're worth. Remember that at this point, our denominators are just going to stay the same. Our radicals are going to stay the same. All we have to do is add 6 and 84, which is 90, and then subtract that 35. So that will give us 55. So our final answer is 55 times the square root of 14 over 14. Nothing is going to cancel here because this is 5 times 11 and this is 2 times 7. They've got nothing in common. Okay, so a quick prime factor analysis will help us determine whether we could cancel anything. If there was a factor in common, we could cancel, but there's not. So guess what? We're done. Did you like it? Did you enjoy it? That was really fun. Okay, that was the part of our lesson that is focused on just radicals. Now we're going to talk about radicals and fractional exponents. The problems are going to look different, but we're just going to pretend it's all the same. And there are 4 examples here, but that's okay. They're going to just whiz right by. Why am I trying to rush our algebra lesson? We want it to last as long as possible. 46.2. Now, these problems are always terrifying when you're first getting started. But once we get the hang of it, we're going to be fine. There's the square root of 3. That doesn't look so bad, but look. Inside the square root, dear Lord, we have another square root. Here's the way we deal with it. That's a C. This won't make any sense until I explain to you what it means. Story of my life, right? Okay, we're going to replace the pig houses with parentheses working from the inside to the outside. So the first transformation of this is to say, okay, the outside pig house we're leaving alone. That we're leaving alone. This is going to become 3 in parentheses with a 1/2. Right? Because we're saying take the square root of 3. This is another way of writing take the square root of 3. Okay? This is what we're saying. And we like to write it with parentheses because it's included in a bigger beast, right? So this is always the way we can change them. Here's me changing it here. Now we're going to change it again. So this bigger one is going to turn into parentheses, right? And we've already got 3 to the 1/2, but now we're taking the square root of the whole thing, right? Because this turns into that. Oh, it's confusing, isn't it? Now, to simplify, we have to remember our power rule. If you're multiplying a number with a base and raising it to a higher power, then you multiply the exponents, right? That's what we've got here. We're raising them to this, so we have to multiply each one by the higher power. We can put a 1 there if we want, if that helps us. Now we'll have 3 to the 1/2, right? Because 1/2 times 1 is 1/2, times, because the parentheses say multiply, 3 to the 1/2 times 1/2, that's 1/4. All right, our bases still match, so that's cool. Now we're gonna use the product rule, because we're multiplying bases that match and they each have an exponent, so we can add the exponents. So we're using the product rule. This is the power rule, this is the product rule. I'm just gonna write that down. Okay, so now in order to finish this, we're going to add these. They both need to have a denominator of 4, so I'm going to change this to 2 over 4, and our final answer will be 3 to the 3/4. That's a rigorous little ride, isn't it? This equals that. It's hard to believe. We replaced the pig houses with parentheses and fractional exponents. I mean, I can't leave them out of the mix. And we worked from the inside to the outside. All right, let's do another, because that was so fun. One thing about fractional exponents, they fry your brain at first, but once you get the hang of them, I think they make you feel really smart. 46.2, my bad. All right. Wait, this is 0.3. Oh my gosh, you know what? You know how I've said sometimes you just make enough mistakes? Start fresh. That's how I feel about that. 46.3. Ready? This one looks a lot like our last one, but on the outside, there's a little 3 in the corner. Huh, all right. Well, we'll figure that out. We're gonna change our pig houses into parentheses with fractional exponents working from the inside to the outside. So, we'll start with this. This stays the same. This pig house goes into parentheses, it's 3. This is just a regular square root one, right? It doesn't have any little number there, so we assume it to be a 2. All right, remember that the number in the pig house always goes in the bottom of the fractional exponent. Okay, so there's the first part. Now we're gonna do the second set of parentheses, go into a pig house. We copy the innards, exactly the same. This now becomes 1/3 out there. We will use our power rule to do that. And that is 3 to the 1/3. Remember, there's an invisible 1 there if you'd like it. Times 3 to the 1/6. And then we'll use our product rule to add them. 3/6, or 1/3 rather, is equal to 2/6. And when we add these using the product rule, it'll be 3/6, and that equals 3 to the 1/2. You would never look at that and think it would simplify to 3 to the 1/2. It's just square root of 3. That's crazy, isn't it? Yes, it is. I hear you. I hear you shaking your head over there in the distance and saying, heck yeah, that's confusing. Okay. Let me do a fresh piece of paper. One more. No, 2 more. Sorry, I lied. I'm sorry. False hopes. 46.4. Here we go. This is a different style of problem. Same ideas, but it's going to look a little different. We're multiplying 2 pig houses together. What the actual heck? Last time we had numbers for our bases, and this time we're in letter land. Well, that's somewhat disturbing, isn't it? Our same strategy is going to work, though. We want to go from pig houses to parentheses. With, look, I'm going to do this, fractional exponents. That's sure reminds us how. All right, this time we don't have layers, right? They're not inside of each other. They're being multiplied by each other. So we don't have to worry so much about from inside to out. That's not our deal this time. Okay, so I'm going to write x to the third y squared. This comes over, and it's 1/2. Then we'll do the same thing here. The inside stays exactly the same. This becomes 1/3 there. Okay, so now I have gotten rid of my pig houses. I'm in parentheses. I'm ready to start using my power and product rules. The first thing we want to do is get rid of this. So we're going to multiply it like so. And then the same here. I'm going to put a 1 there just so that I'm crystal clear on that one. And now I'm going to write these all out. X to the 3/2. Y to the 2/2. And we're multiplying again, so I'm just going to keep the flow going here. X to the 1, it's 1/3, and y to the 7/3. Okay? So now we've got a long line of x's and y's that are being, I was going to say married to each other, but no, they're not. They're each being multiplied by fractional exponents. We want to combine them through the product rule, right? Matching bases, we add the exponents. What I'm going to do is I'm going to take the exponents off and deal with them. 3/2 for x plus 1/3. All right, I'm going to have to do some fractionizing. This one's 3/3. This one's 2/2. That's going to give me 9/6 plus 2/6 equals 11/6. Good Lord, what an unwieldy exponent. And now for the y's. 2/2. I guess that I could write that as 1, but I'll just write 2/2 plus 7/3. All right, well, I'm just going to change this to 3/3 so the denominators match. And that equals 10/3. Whoops. Now I can write my final answer. X to the 11/6 times y to the 10/3. It's my final answer. Okay? So as you can see, in the first ones we had pigs in pigs, pig houses in pig houses. We had numbers instead of letters. Now we've switched it around. We're multiplying two different pig houses times each other, and we've got letters. Does it matter? Is it easier or is it harder? Is it harder? I'm not sure. They're all a little crazy, but I'm not sure one's harder than the other. Let's try the last one. Ready? And it's this second style. Okay. They're neighbors. And again, we're always multiplying these. There's no adding or subtracting going on in these at all. If there were, we wouldn't be able to use our rules for exponents, right? Because those only work to multiplying, dividing, and taking the power of something. So adding and subtracting ruins everything. All right, we change our parentheses into pig houses. The inside stays exactly the same. The number becomes the fraction. Same thing here. The innards stay exactly the same. The number becomes the fraction. All right? I like it. We use the power rule. I'm going to put a 1 there. And now we multiply. X to the 5/3. Y to the, let's write 3/3. We can change that to anything we want it to be when we start to add these together. But we don't know what our other denominator is going to be. X to the 1/4 and y to the 5 over 4. Okay? For our x's, we want to add 5/3 plus 1/4. Okay, least common multiple is 12. So this one's times 4 over 4, right? 5 times 4 is 20. Well, that is not a comfortable looking exponent, but it's right. And then we'll do the same thing with the y. So I'm going to look first. This one's got a denominator of a 4, so I'm just going to change this right away. I'm going to make that 4 over 4. I know it needs to be equal to 1, but I can easily change it, right? And now I don't have to fool around with the denominator drama because I just did that right at the beginning. And our final answer is x to the 23 over 12 times y to the 9 over 4. Lord have mercy, that is a wicked looking answer, but it's right. All right, when you step into your practice problems, I'm going to show you. John gives you 2 of these radical things like we did in the first half. For the fractional exponents, he only gives you this style, pig house in pig house with numbers. He didn't give you any of these other ones, but he gives you these in the work, right? See here in the work, there's the pig in pig, and then this is pig times pig with letters, all right? Again, like I said, I don't think one is easier or harder than the other. They're both just kind of mind-blowing. Okay, guess what? Another lesson, check. 2 more to go before our brains are full for Christmas. Yay! Keep working on memorizing all the formulas and crazy stuff that I throw at you so that when you're ready to take this test, you will know everything and you won't really have to study for the test, right? If you put in your best efforts in this homework, that's the payoff. You don't really have to study, which I'm all for. Okay, guess what? Done. Goodbye.